All right. Actually recording. This is the cell. This is what the cell membrane is made out of. We call it a phospholipid bilayer, meaning that it's 2 layers of phospholipids. You know what? Fine. I like this slide anyway. Take that. Oh, the word's written. Phospholipid bilayer. So pretend that on this side where it's blue, that's everything inside the cell, and this would be everything outside the cell, or vice versa. Inside, outside. Don't worry about the purple things just yet, but this is that's a symbol for phospholipid, like that. And just to remind you about phospholipids, part of this molecule is lipid soluble, and part of this molecule is water soluble. And we use those words, hydrophobic and hydrophilic, to mean something that's water soluble and something that's lipid soluble. Those words are used often. So you've got a layer of phospholipids, and the heads, the hydrophilic heads, the part that like water, are facing towards the inside of the cell and towards the outside of the cell. And the two tails are turned in on each other. And so that's the hydrophobic region in the middle. So it's like this cell, if it were to keep going. So imagine this thing continuing around. And then in here we have like the nucleus and all the organelles. This is like inside the cell, and there's all the stuff outside. So this would just keep going around. I probably have a better picture of it. I'm sure I do on another slide. It's a weird looking picture. What comes to your mind when you see it? This whole thing. I want to see if maybe you think like me.
I was thinking like some, I don't know, bottom of the sea.
That's what I'm thinking. These are like sea worms. This is like kelp or something. I don't know. That's what I was thinking.
That look like some under the sea type shit.
Yeah. So not a very accurate.
Under the sea.
Supposed to be stuff inside the cell, and this is supposed to be outside. I envision it I see it like a room, like this room that we're in. And if you look at the wall, it's there's 2 layers of sheetrock, right? This layer of sheetrock, and then on the inside there's metal or wood, and then there's another layer of sheetrock in the hallway, right? That's kind of what this is. It's 2 layers of sheetrock, right? One layer is facing, so the sheetrock would be the hydrophilic part, and then the wood on the inside would be the hydrophobic part, like the studs. They're probably metal, right? You know what I'm saying? And then you got windows and doors. Those are proteins. So, and you have on the outside of this door, there's a plaque that says B192 classroom. That's a protein, right? That's a protein that labels this cell that we're in. So there's proteins that label the cell, like this cell belongs to Klaus. And there's also windows for some things to kind of, at least you can look out and go out and in, maybe air can come in and out. And then there's doors where people can come in and out. I'm gonna have to move the computer. I'm gonna have to move you guys. that makes no difference for you guys. Just makes a bunch of difference for me. All right. So there's like gates for things to go in cells and out of a cell. And that's kind of what I want. And that's what these purple things are. They're supposed to represent proteins. And so they're telling, so this next slide is just kind of telling you that these proteins have different jobs. It lets cells join together or, whatever. We're going to get to that actually. So, okay. So before I even get to this, let me just write it out. So there's different types. I want to talk about how things get into a cell and how things get out of a cell, because cells are selectively permeable. Meaning that selectively, maybe spelled right, maybe not. I don't know if permeable spelled right or not. I want to see how this spelled last year. I don't need to put nothing up here anymore for the rest of my life. Just all vegging. It's all YouTube videos. Just gonna put Island Boy on a loop. That's it. That's the rest of my life. Not so for you guys. All right, selectively permeable. It lets some things in, but not other things. So I want to talk about how things get transported in the cell or out of the cell. There's two ways that this can happen. It could be passive or it could be active. Whenever you see the word passive or active in sciences, it means with energy, without energy. Passive means there's no energy that needs to be involved. Active means you need to use some kind of energy. So I'll give you like a practical example. When you breathe in, it's an active process, meaning that there's some muscle that's getting contracted to make you breathe in. It's not just happening. But breathing out is passive. Breathing out just because your lungs are like elastic, right? So it's like stretching the elastic. And so that when you go to breathe out, it just snaps back. So you shouldn't be using any energy to breathe out. Breathing out is passive, breathing in is active. So passive transport doesn't use any energy, it just happens. And the main way of passive transport is diffusion, which I forgot how to spell. 2 F's, what do you think?
Sounds right.
I'm feeling better about that now. Diffusion, yes, 2 F's. Diffusion is just when things go from a higher concentration to a lower concentration. Just
I can't see that.
Higher to lower. You can't see it?
No.
Yes, you can.
How you know?
Because I can see it.
I'm gonna show you what I see. All I see is diffuse. What ION? Yeah.
You don't see ION?
Now I see it.
Oh. Okay. When you if you were to spray perfume in like the corner of a room, eventually that perfume is going to reach like every part of the room. Eventually, because it's diffusion. The perfume doesn't want to stay all clustered up. It wants to just keep spreading out and spreading out. People diffuse in an elevator. We don't stay all right next to each other where the buttons are. We spread out naturally. There's a whole body of research about urinal placements, like where guys go in urinals. And there's like, because if you have, this is way more interesting than biology. So if you've got like 3 urinals, you should, when you walk in, we got all these unwritten rules. You got to use this urinal or this urinal because you have to let the other guy, like if someone else walks in, you got to be here so that they can use that one. You can't walk in and take this one because if you're taking this one, you're forcing the next guy to come in to use that one, which means you're secretly sending a signal to them that you want to screw them or something. This is mostly for older people. These were like rules that we had set up. So you got to choose this one or this one. And then if you have 4 urinals, you got to like, if you're here, the next person's got to be here. All right, so we always got to put like a urinal between. And then they did research. They're like, well, what if we put some like dividers up in between the urinals?
It helps.
It helps, but people still generally follow the rules. And we do it with bathroom stalls. Like we try, you can't use this bathroom stall. I can't use that one because I can still see your feet. And that's like not cool for like our rules, right? So there's all these like, and then, then they play with it. The researchers would add urinals in and take urinals out. And then they would they would put in like a trough and see if like people follow rules in that way. They do.
And they, you talk about like those ones that they have at the stadiums. With all
Yeah,
the
yeah.
Yeah, you usually go to the ends. You go to the very corners. And honestly, that's like the one place where the rules kind of go out the window is when you're in a stadium, which is why I think they can get away with the trough, just because there's so many like fucking people.
And you understand that
Like,
that dude's been drinking beer. He's got to go.
Yeah, you ever been to a Saints game? I would tell you, there's like literally all those rules get thrown out the window at a Saints game.
Yeah, because you understand that like they have to go. They're not going to wait until some space clears up at that trough.
Yeah.
But
That's
then,
really gross. There's a smell in there.
yeah. Yeah, guys' bathrooms are. I love the new rules about like genderless bathrooms. I think they're great. That opens up twice as many bathrooms for guys. I think women are the big losers because now you can't sit on that seat ever again. So I don't understand who's like winning it. I mean, I love it when I go to a coffee house. There's like twice as many bathrooms now available. So that's great. And they smell half as bad.
I wouldn't mind if they just got rid of urinals just altogether and just make just more stalls.
Yeah.
Just have more stalls in the restroom instead of just having urinals.
That'd be great. Yeah.
That is beautiful.
I'm fine. I go to the stall first anyway because I don't know.
Is it just because they're afraid dudes are going to piss on the toilet seat? Because they will. It happens.
Yep.
They're going to. Nasty.
Guys pee on the floor. It doesn't matter how big you make a urinal. Somehow they just still pee on the floor. It's like they want to. Like I don't know how it. I don't know. Anyway, glad I got all this recorded. That's diffusion, though. That's an example of diffusion. People diffuse in the classroom. They start filling up the back, but they won't like form a line of students in the back of the classroom. So anyway, things diffuse, and it's really not too difficult. Look, here's the cell, and I've got 3 X's in the cell, and I'm sorry, outside of the cell. I've got 1 X inside of the cell. That means if we follow the rules of diffusion, 1 X is going to go into the cell until they're equal numbers. And then that's it. There's going to be no more movement. Or if I have like that many X's in the cell, 2 of these X's are going to move out until they get equal numbers. And then you won't have any more movement. That's diffusion. That's all. If you look at what like Margaret, what's that?
Sorry, that was my son.
Oh, really? How's he doing? How old?
4.
Oh, perfect year to take a class when they're 4. They don't respect. They don't care that you're in school.
Shh.
He's all right. like when you look at the weather people and they're like going like this and that and whatever, it's always the H to the L, high pressure to low pressure, because that's diffusion. So if we have low pressure here and wherever there's high pressure, there's like rain, that means we're going to get the rain. So that's what cells, that's what cells do. Now, sometimes you got to use like a door. You can't just, because usually what happens, let's see if I can get back on. Usually what happens is that when something diffuses into a cell or out of a cell, it just squeezes in between the phospholipids. So as soon as this lights up, I'll show you. I guess I can erase all this in the meantime. So usually when something enters a cell, there's like two ways to diffuse. It could squeeze like in between. So it'll squeeze right in between here. Or maybe this is like a better one. It'll squeeze like in between, squeeze in between there. Right, but some things are like too big to get in between. So you need to use a gate. I think of like the Superdome or Smoothie King Center. Like you got to use those. Like sometimes they've got like those turnstile things set up, right? But what if you have like a stroller, or what if it's like a group of people, like a whole busload? Then you open like a gate next to it, right? It's still diffusion, but you're helping it. So we call that facilitated diffusion. Anyway, this slide right here is showing diffusion. Right, so higher concentration to lower concentration until you reach an equilibrium, like a balance. Right, sometimes you have to, no, there. Sometimes you need help. So can you guys see this where my pen is? How about now?
Mm-hmm.
So sometimes some things will just squeeze through. That's kind of like what that's doing. That's just squeezing through. But sometimes you need a gate. Sometimes you need what's called facilitated diffusion. And why would you use that? There's a few different reasons. One reason, if it's an ion, meaning if it's charged. Any charged molecule has a special gate that it uses. We call them like channels. Like there's potassium, a channel or a pump. There's potassium channels and calcium channels, and there's all these special doors that ions use. Oh, I'm about to. As soon as I say this, I'm going to stop. Ions use it. Things that are large. And a third thing, because we need three of everything, large amounts. Like water can squeeze through like this up here, but sometimes you want to move a lot of water, like your kidneys. Your kidneys move a lot of water. So they've got like these special proteins called aquaporins, and that moves a lot. All right. So that's a quick introduction. And then, of course, active transport is going to use energy, but we'll talk about that next class. What I want to do now is I want to talk about the quiz. So what are we going to do on the quiz? Well, we're doing metabolism. So let's talk about some ideas that I'm most likely going to ask you about. You definitely need to know the difference between catabolic reactions and anabolic reactions.
And we just talked about that, right?
On Wednesday, you mean?
Oh, yeah, but yep.
Think of anabolic steroids. Anabolic steroids builds muscle. So anabolic reactions build, there's two parts to this. They build molecules. The second
Right.
part of that is that they use energy. Anabolic builds molecules and it consumes energy.
And it uses consume energy?
What's that?
It uses consume energy?
Yeah. So if you want to grow hair, you're making shit, right? That's anabolic. Growing hair is anabolic. But you need energy to grow hair. You can't just grow it.
What about catabolic?
Hmm?
What about catabolic?
Catabolic's the opposite. So when you want to break down food, for example, you're breaking up stuff. You're breaking up molecules. And whenever you do that, whenever you break up your food, you're releasing energy. So catabolic reactions break molecules up, releasing energy. So I'm definitely going to ask you about that. I'm definitely going to ask you about ATP. And that's kind of at least my version of the formula.
And ATP is mitochondria.
ATP is what?
Mitochondria. That's how you say it?
It's made in the mitochondria.
Yeah, that's what I meant.
Which is another thing I want you to know. Yeah, perfect. That the mitochondria is where ADP and P are put together. ATP is the mitochondria. Yeah. No, this is where that's where they're put together. So when I put these two together, when I join these together, what kind of reaction is that?
Anabolic.
It's anabolic. Because I'm taking two smaller molecules and I'm putting them together to make a larger molecule. But if I go the other way, if I want to break this up, into these two, that's catabolic.
So wait, so what do we need to remember? Because
All of that.
So okay, so to break up molecules, it would be ATP. To put it all together, it would be ADP plus P.
I kind of see where you're going with that. To put these together, ADP plus P, that makes ATP. I'll represent these like circles.
I'm trying to figure out how a best way for me to remember it. That's why.
I take these two and I put them together to make that. That's anabolic. If I take this and I split them up to make these, that's catabolic. And you see this D right here stands for di. Adenosine diphosphate, meaning 2. This stands for adenosine tri. That middle number's the letter's important. Triphosphate meaning 3. So it's triphosphate. Then I break this up into di, ADP.
Oh Jesus.
I'm breaking up ATP right now. When I go to take my arm and I go to put it up here, that's because I'm breaking this up into these two, and the P is touching the muscles in my shoulder to let me raise my arm to go like that.
Okay.
And then later on, when I eat food, I got to put the P back onto the ADP so that I can make more ATP. This is the energy. This is how anything that your body wants to do, this is how it does it, ATP.
I think the best way for me to remember it is ATP is split catabolic, and then ADP plus P would be antibiotic because it's brought together. That's the best way to remember it.
Yes. Yeah, you're right. And just remember, whenever I break this up, I've released energy. And it's right here. The energy that I release is here. Whenever I want to put these two together, I need energy. I need to find an energy source somewhere to put these two together. That's going to be next week when we talk about that. So, yeah, I want you to know that. And then I want you to know about enzymes. What are enzymes? Yeah, just like that. What are enzymes? Enzymes speed up chemical reactions. Oh. No test would be complete without the first law of thermodynamics. There's two ways to learn the first law of thermodynamics.
Oh boy.
Dynamics. The first way is to go on the Googles and memorize the definition. The second way is just to know what it is in your head. If I just ask you, like, explain it to somebody, pretend you're going to explain it to a family member. It's in your own words. If you want to try to look from my words, energy is not created or destroyed but transferred. That's fine. But I mean, if you know what it is in your head, then it's easy. Just write whatever's in your head on the paper. I'm not looking for strict definition. I don't care about any definitions. I could give a shit about definitions. I really don't care. I want to know what's in your head. You got a much better chance of getting it right if you put out what's in your head. Let's say that you wrote as an answer, energy is not created, it's just transferred, right? You missed a part. You didn't say energy is not created and it's not destroyed. You just said energy is not created and it's just transferred. Fine. You get it. You just forgot a stupid word, right? I don't care. Like, energy is transferred around. Electricity charges your battery. Then the battery gets used to make your cell phone go. That's transfer of energy. It's first law of thermodynamics. So that's it. So we got 4 things so far from this chapter. Put it it's good enough. Yeah.
Quiz is only going to have 4 questions.
5. So then we got cells. I'm not going to, so cells, I'm just going to do the organelles. No, I'm going to do 2 things. Organelles. We talked about how many organelles, like 8?
Lower the camera.
7 or 8, 9. For example, if I put ribosomes, you put proteins. If I put lysosomes, you put the enzymes. It's going to be memorization. You're going to have to memorize stuff, but it's not hard in that. I mean, it's only memorization. It's only word association. So you just put 20 minutes into it, 15 minutes. There's websites that you can click and it just like interactively teaches you. You can just learn it on your phone. And then the last thing, differences between plant and animal. No, I lied. One more thing. And I'm going to write the words on the test so you won't have to memorize prokaryote versus eukaryote, but you got to know the difference between them. There. Now I'm done. I'm going to put the pen down. I'm not going to pick it up again. Prokaryotes are bacteria. Eukaryotes are everything else.
Wait, so plants versus animals.
Like what's in a plant cell is not in an animal cell. That's what I'm going to want to know.
Chloroplast.
Chloroplast. That's one thing.
Cell wall.
Cell wall. One more thing involves water. That's vacuole. Vacuole. So vacuoles, chloroplast, cell wall, those are in plants. Those are not in animal cells.
So the only thing that we talked about with plant cells and animal cells is the plasma membrane, nucleus, ribosomes, nuclear envelope.
I will not ask you, just to make it a little bit easier, I won't ask you about the plasma membrane, and I won't ask you about the nucleus.
Okie doke.
Just the organelles, you know, lysosome, ER, rough ER, smooth ER, chloroplast, centrioles.
And then I don't know how to say this word. It's a cytose organelles.
Cytoplasm.
No, it's CYTOSOL.
Cytosol. I won't ask you about that. That's just the liquid that everything floats in. But no,
Okay.
I'm just going to stick to the organelles.
Okay, makes sense.
And I've got a Word document that I'm going to post after class, and it will also talk about them, like the organelles. That's way more than I need for a quiz. 5 or 6 questions on a quiz maximum, right?
Definitely more than the first one.
Yeah. But, you know, if I say what are enzymes, you say they speed up reactions. There's different organelles I might ask. You know, I'm not going to ask them all. I'll pick a couple. I don't know. I really don't know. But if I say what are peroxisomes, I'm just looking for the word detox. And when I see that word, then that's correct. All right, I'll move on. 3 things in the plant versus animal. So just write about the 3 things that are in plant cells. That Juan just talked about. You're Juan, right? You're Juan, right?
Yes.
Your test is so easy to grade. Just keep doing them like that. I just like hold it up. Good. Question? A's and F's are super easy to grade. Just do one or the other. Get everything right. And one of you gets everything right with like neat handwriting too. It's one of you guys. It's like super easy. I'm just like this. I'm like done. That paper's graded. I don't have to like put my pen on it except to write on it.
If penmanship was part of the test, I would fail.
Yeah. You're not the penmanship, but I can read yours is one of those that I just kind of hold up, and I'm like 100. If they're all like that, man, my job would be so easy. And then ones where people put nothing, that one's easy too.
Yes.
Everyone else in the middle. Any questions on this? There's no reason, even just 2 days, there's no reason why you can't get all this. I know it's a lot to learn. I admit it, but there's no surprises. You know exactly what I'm going to ask. And they're not paragraphs, like they're not sentences. I don't know. This would be the only thing that might be a sentence. This one, yeah. The rest of this you can answer. Maybe these 2. That might involve a whole sentence. The rest of it's just words. There's no reason why you guys can't just all get hundreds on this. All right. Any questions? So I think we're done. I'm going to stop recording. Stop recording. All right. Well, I'll be able to post that recording. Shh. Shh. You guys are good. Thank you. Glasses. Oh. I'll see you guys Wednesday.
Roger that.
Oh, I didn't stop recording yet?
Nope.